if you take, again, a Christmas ornament, a shiny ball, some people have them in their garden. You have this ornament, like a big ball, shiny, and you break a piece of it. Well, it depends which side you're looking at. If you're looking at the inside of that, if this is the shiny side, it's different than if you're looking on the outside of that. When you're looking at a Christmas ornament, it's like, it looks like a basketball, a small one, like a baseball, and you're looking at yourself through that lens. But when you break that ornament, you look through that inside curve, like this. Now, I'm making the shiny side. When you see me put the lines, that means I'm telling you the shiny side on the inside. The shiny side on this side. When I put the line through this, that means that's the yucky side. The shiny side on this end of it. So we have name for these. These called concave and convex. This mirror is known as concave mirror. And F, which is the focal point, we'll talk about that, it's equal to 1/2 r. 1/2 the radius. Remember, this came from a sphere. We had a sphere with the radius r. You broke a piece of that. You took, for example, for this mirror, you took only, where's my big marker? We came and took this piece. So that's what this one, concave mirror. F, the focal point, is 1/2 of the radius. Now again, this used to be part of a sphere. This is the radius. This is called convex mirror. And F is actually negative here. It's on the opposite side, negative 1/2 r. Because it's going to be here, the focal point. What does that focal point means for concave and convex? For concave mirror, that means if you take one of those mirror, concave, what the focal point means, if you shine light at this one, if you shine a light straight at that, it's going to deflect through that. But if it's higher, the deflection is going to go through this point, somewhere here. And if it's this one, if the beam is higher, the deflection is going through that point. If it's down here, going in, the deflection is that one, or reflection. So this is what the focal point is, where all the beams cross, meet. Satellite dish is designed based on this. When the dish is round and the receiver sits right there, because they want, when the signal hits it, it's going to deflect off that. They want them to meet at this spot. If you go and move it, put it right there, you're not getting all the signals. You're getting a weak signal. You might not even see anything. So when they come and tune that, they try to find out, did that receiver move? It's supposed to be at that spot, this height, right there. If it's there, it will pick all these signals. So that's what the focal point is. So if we're going to show you now, how do we trace through concave? We'll do concave now. How do we trace what a picture is going to look like in a concave mirror? And that's where the graph paper comes in. Ray tracing and the mirror equation. It's a good idea to have a graph paper, so if you need some, grab some right here. I have plenty of it. I have rulers if you need one. I don't like this rule, it has a little metal on it. I keep catching that edge of it. And let's graph this. To graph them, so this topic is going to be called ray tracing and the mirror equation. We'll do ray tracing first.